OK, so the first part of our strategy was, can you avoid using the database by aggressively deploying caching in front of it? Supposing you can't do that and you have to go to the database, the next best thing to do is make sure that you don't mistreat the database so that when you actually are trying to use it, you're using it in a sensible way. And remember that the price of this is that if you outgrow the single machine database, you all of a sudden start having to manually deal with a lot of things that cause you to build new infrastructure. So whether you're doing sharding or having multiple copies of the database and turning master-slave replication on, that's sort of one more thing you have to worry about. So how do we relieve the pressure on the database to avoid getting in that situation? We already talked about caching. That lets us hopefully avoid doing certain queries at all. And we're going to talk about two other things we can do that are sort of very easy to make errors. One of them is called the n+1 query problem. It's when you could get away with making a single query, but instead you make n+1 of them to retrieve n items. And you can use indices to speed up the queries that you do have to do. So each one of these is sort of another layer of protection, right? It's like a multi-layered approach. So what's the n+1 query problem is you're traversing an association, and you write your code to do it in such a way that where you could have just had a single database query to pull out all the information you needed, you end up having to do n+1 of those queries. And let's skip straight to an example, because it's actually easy to see once you... OK, good. You guys can see it, I hope. So here's an example of an n+1 query problem. We have, let's assume that we have the moviegoer class, and a moviegoer has many movies through reviews. So we're trying to figure out, we've figured out here's all the fans who live in a certain area. And for each one of them, we're going to look at all the movies that they rated, right? So remember, this is because it's a through association. Even though the fans write reviews and the reviews are about movies, if we traverse that association all the way down, we can ask the question, what are all the movies that any given person has reviewed? The problem with this formulation is that when we do this query, what we end up getting back from the query is essentially an enumeration of moviegoers. And now, for each one of those moviegoers, we're going to do another query to do the through association traversal to get all the movies associated with that person. So that's why it's an n+1 query problem, right? Here's one query that's going to return n things. And then for each of those n things, we're going to do another query that happens in the view. A much nicer way to do it is if we know in advance that we're going to want to traverse the association, we can actually do, remember how we talked about lazy loading, right? Which is when you write an active record query and the query doesn't actually happen until the first result is pulled out of it. The opposite of being lazy is being eager. And we can do an eager loading as well, which means in the controller, not only are we going to do the query we actually want, but we're going to say, along with that, include all the movies, meaning traverse the association at the time this first query is done. So in the parlance of relational databases, whereas in this example, we were basically doing a query on a single table, when we add includes, it turns the query into essentially a three-table join, right? Why is it a three-table join? Because we've got to join the moviegoers on reviews and then join reviews on movies. So it's 3 tables total are participating in the join. Now, that sounds like it's a lot more work, but given that databases are highly engineered to do this kind of work quite efficiently, the upside of doing it this way is once you're in the view, you've got 0 queries left to do. Because at this point, the fans data structure already contains the nested information of movies associated to each moviegoer, so that when we have a view where we're iterating over these, there's no additional queries being done in the view. So we've gone from doing n+1 queries to doing just a single query in the controller. And because controller actions tend to be pretty closely coupled to the views that they generate, it's quite reasonable to think in advance in your controller action, what data am I going to use? If I'm doing a query on a particular model, but I know that the view is going to display other information that's joined to that model, then it makes sense to use eager loading in the controller method and essentially get all of the querying out of the way all at once. By the way, the opposite of eager being good is eager being bad. That's basically when you needlessly load all this stuff in the controller method, but then in the view you don't actually use it. So how would you know if you're either using eager where you should not be using it, or if you're not using eager and you should be using it? As you might expect, because this is a common problem, there are gems that will help you do this. The gem that I have used in the past is called Bullet, but I'm sure that there's others. And it actually helps you find both scenarios. It helps you find places where you're doing n+1 queries that you probably could replace with a single one if you did eager loading. And it finds places where you eagerly loaded information. In other words, you did table joins, but you never used that information in the view that you rendered. There's a lesson in this, of course, which is a lesson that we've seen before. And the lesson is that all abstractions eventually leak. Remember that the goal, or one of the goals of the active record abstraction, is to let you believe that you're working with this graph of objects in memory, even though the way those objects are stored and connected to each other is through database tables and foreign keys. Well, here's a place where the abstraction leaks, because in terms of what you get as the output, there's no difference in the output between using the eager loading version and the non-eager loading version. But there's absolutely a difference in performance, because it's the difference between doing one query and n+1 queries. So that's why the abstraction isn't perfect, right? It can't hide from you the fact that there's a non-trivial performance implication associated with something that doesn't affect the correct behavior of the code. The last thing we can do to be nice to the database is we can judiciously use indices. And roughly speaking, think of this as think of an index as having a hash table that allows you to quickly go to rows of a database that have a certain value in that column. So for example, if we did movie where rating equals PG, then if you didn't have something like the equivalent of a hash table data structure, the only way to do this query is to scan the entire table, which means that the query takes linear time in how long the table is. On the other hand, if you built an index over it, you now have the moral equivalent of a hash table that you can immediately find, right, roughly in O of 1 or constant time, all of the rows where this column constraint can be matched. And if the attribute is uniquely valued, for example, if you have users with email addresses and you're not allowed to have duplicate email addresses in the table, then the win is even bigger, because there's basically no collisions in the hash. Now, you might think, if that's such a good idea, why doesn't the database just do it on every column? Why do we have to worry about it at all? And roughly, the answer is that, first of all, each index takes up space, right? In general, the index takes up space proportional to the table size. So if you've got a large number of very large tables, the size of the indices starts to become non-trivial. And second, every time you update a table, you have to update every index that might be affected. So if I have an index on email addresses, let's say, and I add or delete rows in that table, I have to modify the index function to make sure that it knows about the rows that were changed or deleted. Having said that, unless your tables are ungodly large, you can actually index a large number of individual columns in tables, and before you have to start seriously worrying about performance effects. So what could you use this for? Well, certainly foreign key columns, right? Anytime that you're doing a join, that means that you're joining on the movie ID or something underscore ID fields of multiple tables. That means that at some point in the algorithm, the database is going to have to look up all of the rows in the table where the movie ID matches some value, for example. So having an index on the movie ID field would really help you. And generally speaking, anywhere that you have a foreign key that participates in a join, you might as well have an index on that foreign key. Columns that appear in the where clause. The where clause is basically a signal saying, these are the attributes that I care to search on. So in our simple example, we showed searching on a movie by rating. That means having an index over ratings will greatly speed up this query. Why? Because the alternative is do a table scan, which is linear time, look at every entry in the table, and figure out one by one which ones match. Columns that you're going to sort on. If you're using any of the active record features that let you pass arguments down to the database so that you're returning records in a particular order, having indices on the things that you're sorting by will speed up the sorting operation. And surprisingly, as you might guess, there's yet another gem. Again, I use this one, but there's probably others by now. Rails indexes will help you not only identify missing indices, but it'll help you identify indices that you created, but that there are no queries that benefit from them, or queries the queries that benefit from them aren't executed terribly often. Just as with caching, we can also ask, how helpful is it to use indices? And this reproduces a table from the book where we did another sort of micro-benchmark experiment. We had 3 scenarios where we had 2,000 reviews in Rotten Potatoes, 20,000, and 200,000. And for each one of those scenarios, we timed how long does it take to read 100 reviews according to some criteria with no indices, and then reading those same 100 reviews, but now having some indices on the criteria and on the joins. And you can see that the larger the table gets, the bigger the overall performance win is, right? So indices help you a lot because, again, what you're really doing is buying yourself more users that can get interactive performance before you're forced out of the past tier. Now, we said there's some overhead associated with indices, which is that now every time you modify those tables, you've also got to modify any indices related to those tables. So what's the cost of that? Well, again, using those same examples, when you get up to 200,000 reviews, there's about a 17% performance decrease compared to when you update the table with no indices versus when you update the table with all indices. So for all indices, we took essentially every pair of columns that you could take in every table and created composite indices over every pair. Right? So it's sort of the number of different columns squared is the number of indices we had, which is pretty severe. It'd be very unusual for you to have that many indices related to all of your tables. And even in that case, we had to really crank it up to 200,000 reviews before the performance difference was really noticeable. So when in doubt, indices are a great thing to use, especially if you have a gem like Rails indexes that helps you figure out where you forgot one. So here's a question about indices with that in mind. Suppose we have that relationship of movie has many moviegoers through reviews, which we've seen before. Which foreign key index would most help in speeding up this query, where given a movie, I want to now dereference all the moviegoers who have ever reviewed it? So this is, I'll give you a minute to think about this, because you need to think about how the join is going to work and which foreign keys participate in the association.